Okay, we are in Algebra 2, Mod 8. It is now Wednesday, April 15th, 2020. Yesterday, on Tuesday, the 14th, we did the first of our conic sections, and we learned how to graph circles. Now we're going to move on to our second topic of conic section, called ellipses. Ellipses, instead of perfectly round circular shapes, are more elliptical or oval or egg-shaped. And that's our goal, is to draw ellipses today. We're only going to do 4 of them. So this will not be a long assignment, but it's critical that you pay attention so that, again, you know the details as to how to set the pictures up and draw them accurately, okay? So for your notes, top corner, go 4-15-20, Wednesday the 15th. Title is Ellipses. I'm going to do one problem in each block on the front of my paper. Go to block number 1. Go ahead and write x squared over 4 plus y squared over 25 equals 1. Okay, a couple things very important to point out. So again, please stay with me, think with me, concentrate on the details. Don't just copy and have your mind elsewhere as you're focusing on taking these notes. Okay, let me point this out. If there were not any numbers on the bottom and it just said good old x squared plus good old y squared equaled, and then there's a number on the right side of the equal sign, remember when it was x squared plus y squared equals r squared, that was a circle. Obviously, we've still got x squared plus y squared, just like yesterday on the circles, but the x squared has a number under it, and the y squared has a number under it. So as soon as you see the x squared plus the y squared scenario and see numbers underneath, that's telling you that this is an ellipse and not a circle. The other thing to point out, an ellipse is always in, quote, standard form when it's equal to the number 1. So this first problem is equal to 1. And if you sneak a peek down here at this third problem, it's also equal to 1. So every time it's equal to 1, that's what you want, because that's called standard form. Now, notice, if we did stay with comparing these two problems, that's plain old x squared and plain old y squared, telling me the center of this picture is probably what? 0, 0, correct? Whereas down here, just like yesterday, when the x has a number attached to it and the y has a number attached to it, then the center is going to get moved somewhere other than 0, 0, okay? So if we go to problem 1, and I'm going to graph this ellipse as neatly and as accurately as I can, just like the circle we had to figure out where the center was. Well, for an ellipse, we need to know where the center's at. And the center of this ellipse, since it's plain old x squared and plain old y squared, is indeed 0, 0, right on the origin. So let's put a dot on the origin and put a little CR there for center. And now here's all you've got to do. If this was a circle, you'd have a perfect radius the same distance in each direction, remember? Well, here's all we've got to do on an ellipse. Since the x squared has a 4 under it, okay, the square root of 4, because you're thinking, what number would I square to get 4? Do you agree the square root of 4 is 2? Oh, and since that's under the x squared, and the x-axis runs left and right horizontally, that tells me to go right 2 and left 2. So again, since the x squared runs left to right, and the x squared has a 4 under it, I go right 2 and left 2. So if the y squared has a 25 under it, now of course the y-axis runs up and down vertically, correct? Since there's a 25 under there, the square root of 25 is of course 5. I'm going to go up 5 and down 5. And now when I connect my dots, it's obvious it's not a perfect circle, but rather an oval or an egg shape. Looks like a football sitting upright on a tee there. and it's an elliptical shape. This is called a vertical ellipse because it's elongated vertically because the larger number was under the y-squared. So that's the general process for graphing an ellipse that's in standard form. Now if we sneak ahead to number 2 here, it says 4x squared plus 9y squared equals 36. Careful. Remember I pointed out that an ellipse is in standard form when it's equal to 1. It has to be equal to 1 before you can attempt to graph it correctly. So obviously if this is equal to 36 and it's not equal to 1, we've got to correct this, and we're going to have to do something algebraically to, quote, get it into standard form. So guys, we're going to divide both sides by 36 because we want that to be a 1 on the right side. So obviously 36 divided by 36 creates the one we were seeking. Now on the left side, you're just going to cross cancel a couple of times. Do you agree that this is 4 over 36? And remember, I divided the whole side by 36, so my second fraction is 9 over 36. So just doing a normal cross canceling here, the 4 would cancel and the 36 would become a 9. So I've got x squared over 9 plus, and then 9 over 36, the 9 would cancel and the 36 would become what, a 4? So I've got y squared over 4 equals 1. There it is. I was able to divide everything by 36 and very calmly got it into standard form. Now, just like that last ellipse, the center of this one, since it's just good old x squared and good old y squared, is of course 0, 0, right on the origin. The x squared has a 9 under it, so I go to the x-axis and I go right 3 and left 3. The y squared has a 4 under it, so I go up 2 and down 2. I square rooted, of course, both those numbers. Connect them up. I again have an oval or egg shape. It's elliptical in shape, but it's a horizontal ellipse because the bigger number was under the x. Okay? Third block. Oh, it's in standard form because look, it's got x squared over a number plus a y squared over a number, and it's equal to 1. We want it to be equal to 1. This ellipse, however, will not be centered on the origin. Agreed? Just like when we worked with circles, since it says x plus 3, what's the opposite of plus 3? Negative 3. It says y minus 1. The opposite of minus 1 is positive 1. So the center of this elliptical shape is going to be left 3 and up 1, so it's up in quadrant 2 at, whoops, let me make sure you can see that. Again, the center was negative 3, 1, so I went left 3, up 1. There's the center. Always label it so I can see where it's at. Now careful, these happen to not be perfect squares underneath, so what? Our job is still to square root each one of the numbers that are on the bottom. So if you take out your calculator, the square root of 12 is 3.5. And since that's under x, I'm going to go right, 1, 2, 3.5. And I'm going to go left 3.5. When I look under the y value, there's an 18, and the square root of 18 is actually 4.2. So I'm going to go up 1, 2, 3, 4.2, and down 1, 2, 3, 4.2. So this elliptical shape is elongated up and down. Draw it as neat as you can, and it looks like that. Okay? Finally, last one, and we're done. 5x squared plus y minus 2 squared equals 20. Okay, now careful, guys. Do not divide both sides by the 5. I don't want the 5 to be gone. I want the 20 to turn into a 1. Agreed? I'm going to divide by 20. Divide by 20. It does indeed turn into a 1 on the right side. On the left side, you very calmly just cross cancel or reduce. 5 over 20 reduces to what? 1 over 4. So that'd be x squared over 4 plus y minus 2 squared over... Now notice that y minus 2 squared did not have a number in front of it, so the division by 20 makes it stay a 20 underneath. So 5 over 20, the 5 canceled, the 20 became a 4. This was 1 over 20, so the 20 did stay on the bottom. Point is, I got it into standard form. I'm going to go try to graph it correctly. The center of this ellipse, notice the x squared does not have a number beside it attached to it. So my x coordinate is 0, and my y coordinate, since it has minus 2, is actually going to be 2, correct? So the center is at 0, 2 right there. Again, I'll put CR for center. Since the x squared has a 4 under it, I'm going to go to the center, and I'm going to move right 2 and left 2. Since the y squared has a 20 under it, and the y-axis runs up and down, I'm going to take the square root of 20, which is 4.5, and I'm going to go up 1, 2, 3, 4.5, and down 1, 2, 3, 4.5. And you've got a really thin or narrow ellipse, again elongated vertically, that looks like that. So guys, after 2 days, you're an expert on graphing circles. And now when you've got elliptical or oval shapes, you can also graph what are called ellipses. Okay? Homework or your assignment. Again, today is Wednesday, April 15th. This is due tomorrow at noon. Guys, we're doing the same routine each day. This isn't due tomorrow at 6 o'clock p.m. We're not doing this at your convenience. Set up a daily routine, some kind of discipline. If you're watching this truly on Wednesday today like you should be, there's no reason you can't sit down right now when you hit stop on this and do these 4 problems in about 5 minutes and send me a picture when you're finished. But they're due by certainly tomorrow, Thursday the 16th at noon. And it's these 4 problems right here. Okay, all you've got to do, copy all 4 of them down. Obviously, 2 of them are already in standard form. That'd be number 2 and number 4 because they're both equal to 1. Number 1 and number 3, you might have to divide or do something algebraically to get them into standard form. But the point is, give me a nice, neat graph of all 4 of those and send it to me when you're done. Okay? Thursday and Friday will be our last 2 types of conic sections. Thursday, tomorrow, will be hyperbolas. Friday will be parabolas. And then we would wrap this entire unit up with a little exercise next Monday. Okay? Good job. We'll see you tomorrow.